So let's get started. We've got a couple minutes, and I'm sure some folks will meander in. So my name's Kevin Shelly. I'm with MarkLogic. Just curious, how many of you have heard of MarkLogic or are familiar with the term called NoSQL? Okay, not many. So we got one. All right, so this is going to be a learning experience for a lot of you, which is terrific. So MarkLogic, we are a privately held company. We're out of Silicon Valley. We finished last year's revenues about $120 million. We've got offices in San Carlos, Chicago, New York, Washington, D.C., Tokyo, London, Singapore, Berlin, probably a few other places that I've missed. So we're growing because we're in this whole big data space. So you've got your data, right? So what does that mean? I suspect it means that your data is all over your organization. It's probably in the cloud. It's probably in Hadoop. Could be on a laptop, could be on servers, could be on a thumb drive, right? So you've got your data. The question is, how do you bring it all together and harness it so you can get value and deliver insight to your constituents? So what is the value of data? So let me ask you a question. It's not a trick question. It's actually pretty easy. So what are the top 5 companies in the world in terms of market capitalization? Come on, it's not hard.
Oh,
Where's my iPhone?
Apple iPhone?
Okay, so Apple is 1. Google is actually 3, according about a week ago. So Microsoft was 2. ExxonMobil was number 4, and Berkshire Hathaway was number 5. So Apple was incorporated in 76, Microsoft 75, Google in 98, and all 3 of them have surpassed the largest oil company on the planet. ExxonMobil has been around since the 1800s. And as the economy grew and we had a manufacturing-based economy and an oil-based economy, we're now in a data-driven economy. So if you look at Google, in the space of, 17, 18 years, 2 guys in a garage have surpassed the world's largest oil company, right? So data is incredibly valuable. And if you think about it, countries have gone to war over oil. And let's hope they don't go to war over data, right? So I'm from Washington, D.C., and it's in the newspapers all the time about government agencies spying on people and getting information. It's all about the data. So what's the value of your data? So data is a resource. Data is a resource and should be treated as such. So what is the value of precious metals, oil, water? What's the value of it? I would say that there's no value to it until it's applied to something. Just like data sitting in your repository. By itself, there's no value. The water in that glass doesn't have any value until I drink it. Or I water my flower. Well, you probably don't want to water your flowers because I think there's a, you can't do that, right? But the application of water, the value is how it's used, right? You can push it through a dam to create energy. You can drink it to provide health and sustain life. You can push it through an irrigation system to grow crops and agriculture. And you can use water in manufacturing processes for those goods or services that you use daily. So the value of any resource is derived by its application. And that's how you should think about your data, right? How are you applying that data so it's of value to your constituents in your organization? So time to value. right? That is essential in any program or any project. So you've got this data. How do you deliver value quickly to those that need it? Currently, it's very hard because we're using traditional technologies and methodologies that inherently they're slow. So how do you turn that journey from ingesting the data to getting value from it? How do you make that a smooth ride across a very scenic road and you get to your destination quickly? As opposed to what I think a lot of you are experiencing is you're getting data and then value from it is probably a journey fraught with starts and stops, accidents. It's like a commute on Interstate 101 or whatever the highway is, or highways are around here that's congested, right? So you need a platform or some type of architecture that is able to have agility and scale quickly. So architecture that you put in place is the key to developing your applications and being able to handle all of the data that is coming at you, right? So the pundits will tell you that we will create more data in the next 5 years than in all of the history of mankind. So think about that. We're on the treadmill running as fast as we can. Now you've got to run further. You can only run so fast, right? So we're falling further and further behind as we use the traditional technologies. So variety. So there's big data, there's the volume, there's the variety, there's the velocity. I would submit to you that the problem that is causing IT departments and organizations is the variety of the data. Data started out where most of it was structured data, which fit very nicely into rows and columns. But today, almost 90% of the world's data is unstructured. So it's not suitable for relational repositories. So you've got two choices. You can continue down the path and use the structured data that you have and leave the other 90% on the cutting room floor. But I think the real choice you want to make is, how do I move to an architecture that's going to enable me to ingest 100% of the world's data? Structured, unstructured, polystructured, semi-structured. And it's the unstructured data that is so rich in content, right? The unstructured data. So these phones, you know why they're so popular? It's not because of email. It's because the data that you can peruse is so rich in content. It's photos, it's videos, it's social media. Not only can you peruse it, you create it, right? So more and more of our data is going to be of the unstructured variety. So how do you handle structured and unstructured? How are you handling PowerPoints, social media, contracts? Wouldn't that be nice to put it all in one repository and it's immediately searchable and can be leveraged by your applications? So I would suggest to you that's not the case today. So data integration is hard. It's very hard. So we've got all of this data that we want to utilize for our applications to provide better services to the citizens. And more is being created all the time, but to harvest it, it's really hard. How do you harvest data and bring it all together when the data is constantly changing, it's in different formats, and it's in multiple repositories across the organization? It's really hard. So part of this, I would say, is a technology issue, but I would also say part of it's a people issue. Change is hard. And when you come up against tough problems, there are those that will say, let's try this. And then there are those that will say, we can't do that because we've always done it this way. Right? Change is hard. But without change, there's not progress. And more data is being created, and we have to get in front of it, because if we continue to use the same processes and methodologies that we have today, we'll fall further and further behind. You can only throw so many people at the problem. So you need to think a little bit differently, think out of the box or get rid of the box, think about something new and innovative. So if you look at the existing operational databases and ETL tools, they've served organizations very well for quite some time. But what's happening now is, as we get more and more data, we're spending more and more time extracting, transforming, and loading data. We're spending more time doing that, as opposed to spending our time creating value and developing new applications. So there's a trade-off. Moving data, which is almost maintenance mode, as opposed to enhancement mode and creativity mode. And if we're getting more data, we're going to be spending more time going through the ETL process, which is just simply moving data. So again, if you look at the 12% of the structured data in the world, that's what most people are harvesting. There's the other 88% that we're not using to fulfill our mission, whatever it might be, whether it's protecting the homeland or providing better health care to the residents or simply making government services more efficient. So we've got to do something different. So the endless cycle of data normalization. So you get your data, you take a snapshot of it, right? And then, based on that initial view of your data, you've got to build a data model, right? So that while you're building that data model, you can't predict the future. And if you can, you should be doing something other than building data models for databases. So you're building this data model that is very rigid and very brittle. And you can't predict the future. So then you extract, transform, and load the data, and then you're all set. You're ready to go. Then legislation changes, and you need to add some additional data sources, or requirements change. Well, guess what? You got to start this process all over again. And as we get more data and requirements change, you're going to spend time going through this cycle of normalization, which is very slow. It's laborious. And if you're doing this, you're not developing applications to serve your constituents. This is almost maintenance mode. You're on the treadmill and you just keep running. So a lot of questions. How many folks in here are using relational databases? Okay, just pretty much everybody, right? So you like building data models? No, that's not fun? All right. Well, okay, we'll get rid of that for you, right? But when you're building that data model, how do you determine in advance what's going to be useful? You don't know, right? So there's lots of issues with the current method of doing things. How many people have been through this? Well, I've got to move this data. You go to the user and they say, hey, I like the application, but I need to access this data. Happens all the time. It's a waste of time. It adds additional complexity, and it's just inefficient. ETL, how many of you folks ETL data? You're the one guy up here doesn't want, it's hard, right? It takes a lot of time. And it's, as we get more data, it just becomes continuous, and you're on the treadmill. Anyone building out a big data platform or trying to or looking to head down that path? So what's your, how many different vendors do you have in that solution?
Right now, we only have 2.
Okay.
That would do it in reason.
Okay. Are you going to add additional ones? Okay, so there's no easy answer out there. A lot of the big data solutions, you've got proprietary hardware. They're engineered systems built specifically for big data. They're somewhat proprietary, meaning they lock you into particular software vendors. And then on top of that, maybe you need to use Hadoop. Then you got to throw in search capability. So it can be very inefficient, time-consuming, and very costly. So there's a lot of confusion about how to go after this. How many of you folks have multiple copies of data in your organization? Everybody, right? So that causes a litany of problems. So one, what happens to your data governance if you've got data governance, right? Which one is the master copy, right? How does this affect my security model? Who has access to it? How long do I need to maintain it? And your storage vendor will love you because you've got multiple copies of data in your organization. So these are all of the problems and questions that are facing folks in government and business across all verticals. So data integration with a relational database. Doesn't matter what kind of database, relational. So every time you introduce a change or add a new data source, you need to add or develop a schema. So even if all three of these data sources on the side were the same as the data source in the middle, all from the same vendor, the schema is not going to work because there's probably not one schema that's suitable for all those data sources. So even if it's the same vendor, you're going to have to go in and build a new schema. And then once you build that schema, if you want to add another data source, you get back to the schema, and of course you've got to extract, transform, and load the data. Wouldn't you rather spend your time developing applications? So data integration with enterprise NoSQL. Okay, so NoSQL means, anybody would know what NoSQL means?
Not only SQL.
Very good, Rebecca. MarkLogic sales rep, Rebecca Morales, very good. So it's not only SQL. We do SQL, but also a lot of other things. So one of the things about SQL that makes it so popular is it's schema agnostic. So all that upfront data modeling, a NoSQL database is not dependent on the upfront data modeling. You can ingest your data as is. In MarkLogic, because we've got integrated search, it immediately becomes searchable and can be leveraged by your applications. Wow. I don't have to do the upfront data modeling. All right? So your time to value is so much quicker. Get the data in there, start playing with it, iterating on it. It's a catchy tune. So you spend less time doing the ETL stuff and more time creating value. Okay? So for the gentleman taking notes in the back, we can give you a copy of this presentation. So again, it's completely different than the way you're doing things now. Right? I mean, I talk to people about MarkLogic and NoSQL, and many of them, they put their hand up over their mouths and they're smiling and laughing, and they say, well, Kevin, this is impossible. I'm a relational database administrator. You can't do this. So yes, we can. It is diametrically opposed to the way you're currently doing things. NoSQL and MarkLogic fundamentally change the way you develop systems and applications. You think completely different. So part of it is technology, but the other part is people to embrace change and new ideas. So data integration with NoSQL. Ingest data as is, and it immediately becomes available to your applications. and you continuously iterate, refine, and bring in new data sources. The idea is let's get the data in there, let's start playing with it, let's iterate, let's build out dashboards, reports, analytics, real-time alerts. It's about getting value from your data now. So there's a generational shift in the database market. So the first databases were mainframe-based systems. You couldn't separate the application from the data. They weren't very flexible. They were hardware-specific, application-specific. And then all along came the relational model. So the relational model has been the model that we've used for about the past 40 years. If you think about some of the vendors out there, their database may be the most successful enterprise software product ever. It has dominated the relational field. Okay, and one of the things that made it flourish, there were tremendous advancements in technology. It came out, people embraced SQL, and the beauty of the relational database is it was available on just about any platform. PCs, Unix servers, mainframes, so you could run it anywhere. You weren't beholden to centralized IT. And back in the day, it was, the network is the computer. Or maybe it was the computer's the network, I forget. But you could network these devices and you could do distributed database. So the users had a tremendous amount of freedom. Relational database has gotten much better the past 40 years. It's got terrific security, it's got great high availability, disaster recovery, it's easier to use, but one thing has not changed. It's still the relational model. The relational model is rows and it is columns. And that is suitable for structured data. So the relational model has not changed, but the data has changed. So a little bit of history, I'm dating myself. I worked for Oracle as a new sales rep in 1988. So what I am doing today at MarkLogic parallels what I did at Oracle. I was evangelizing new technology. I started at Oracle, they were about $150 million. I left and they were several billion. And I would go around and I would talk to people about the benefits of this new technology. And some people just, I'd get the Heisman. And then other people, typically folks who were in distress, right? They had a program that was failing and they were getting hammered. So they were more apt to try something new because they were in a very uncomfortable situation. That's where I am now. It's the same dynamic. It's new emerging technology. And I am going to make a very bold claim. NoSQL databases, it is not a matter of if, it's when it becomes the mainstream database. Because the advantages of it are extremely compelling. Ingest any kind of data. Forget about the data modeling. Immediately become searchable, can be leveraged by the applications. And we have a whole host of customers that I suspect have applications very similar to yours. We've got MarkLogic running in most of the intelligence agencies in the United States. We're on Wall Street. We're in the state of Minnesota, New York City, and some other examples that I'll talk about. So there's a shift happening, and it's all being driven by the different data types. So enterprise capability, right? So when you look at your relational database that you're using, this is what you love about it, right? It's ACID, right? So an atomic transaction would be all parts of a transaction must succeed or all roll back, right? So you get a consistent view of your data. It's not one or the other, right? Think of the banking transaction. I debit this account, I credit this account. If only one of those transactions commits, you have a data integrity issue. Your relational databases do this for you. They also provide great security, right? The relational model is rows and columns, so they provide cell-based security. Terrific stuff. And once you commit your data to the database, it will survive a systems failure. That's what you love about the mature technologies such as the relational database. Well, I will tell you, MarkLogic has all of these. Because if we're going to ask you to change, we are not going to give you something that's less than what you have. Okay? So MarkLogic is ready for the enterprise. So, kind of some differentiation between MarkLogic and the relational players. And we haven't really talked about open source. So funny thing has happened as this whole big data movement has emerged. All these open source companies are scrambling to the trough to get fat on the trough of big data, right? New companies showing up all the time. There's probably 100 different open source databases. Might be more than that, okay? But the problem is they're only a year, 2 years old. So all of those features that we talked about that your relational database has, they don't have them, right? So most of them have this thing they call eventual consistency. Does that sound good? Right? And it's, hey, we'll have eventual consistency. That's not something I want to do. So all the things that we can do out of the box, you can do in open source if you have unlimited amounts of time and unlimited amounts of money. And I suspect the implementation won't be as good as it is with MarkLogic. So healthcare.gov. Y'all familiar with this program, the Affordable Care Act? So let me tell you a story. So this contract was awarded. They had set a stake in the ground that it was going to go live, I believe it was, October 2013. So this program was flawed from the very beginning. First off, it was, and the visibility was just amazing because it's, they call it Obamacare where I come from, right? It's named after the president, okay? And he checks up on it all the time. So when this thing launched, it was a disaster. Right? Certainly changed my life for several months. So there's lots of problems. There was little or no testing before it went live. The infrastructure was hard. And when the website went down, there was no way to find out the root cause of the problem because there was no standard configuration. So if you check one VM and it's the same configuration on the same box for 100 of the servers, fine. You do one check and it's good for all of them. There was no standard configuration. So when something went down, you had 33 vendors yelling at one another, protecting their own turf, pointing the finger at the other guy. And MarkLogic was at the very end. MarkLogic's down, right? So MarkLogic was the engine, but the engine couldn't run if it didn't have gas or oil, or the car couldn't run if it didn't have tires. So this thing, it was crazy. So I get a call. I tell my wife I won't be home for dinner. She goes, why is that? I said, well, I got to meet with some folks in the White House. That changed my life forever. So my wife talks to the in-laws. Well, how's Kevin doing? He says, oh, well, he's meeting with the White House. The website's down. So I got calls every single day. How's Kevin doing? Well, what do you ask? The website's down. Like I was going to fix it and I was meeting with Obama. So my family thinks I'm a lot more important than I am. Never met Obama. Met with the White House CTO, Todd Park. and we rationalized the infrastructure, we pulled it together, and finally we got this program back on track with a lot of hard work and a lot of inspiration and technology that was terrific. And this is one of the most proud moments of my professional career. So why did they select MarkLogic? Well, at first they didn't. They selected a relational database. So after about a month or so, CMS comes to them and goes, not happening. That's not going to work. I said, why is that? Okay, so there's 50 states. We don't know how many states are going to utilize the federal exchange. Okay. And even if we did know what states were going to use the exchange, how are we going to get all those states to agree on a schema? Fair question, right? So how do you build a data model when you don't know who's coming? You use MarkLogic. So it ended up being 26 states use the federal exchange. So which is what they called the HIM, Health Information Marketplace. You get an impossible data model, right? And even if, let's say you got that data model built, guess what? Oregon failed. So now we got to add Oracle, Freudian slip, Oregon. How do we add Oregon to that data model? What you work so hard on, you've got to go change. So that's what you all are doing, but it's just a much smaller scale. You work like heck, you fix it, it's up and running, and then you got to change, so it's 2 steps forward, 1 step back. So with MarkLogic, so we're in the health information marketplace. So when someone wants to come and enroll, they're using MarkLogic. All the health insurance plans in multiple formats are in MarkLogic. So I want to peruse those insurance policies. MarkLogic serves them up. So I give you my information for eligibility determination. All that personal information goes into MarkLogic. Now that you've given me that information, I need to verify you are who you said you are. Also part of the determination is you give me your income. So I got to verify that information. So there's a piece called the DSH, which is the Data Services Hub. So MarkLogic in the health insurance marketplace spawns a process over to the Data Services Hub, also MarkLogic, and then MarkLogic connects with a variety of back-end federal systems. So we go to Social Security to validate that your number you gave us is correct. We go to the IRS to validate the amount of money you made is correct, because the amount of money you make determines the subsidy on your plan. All of this is in MarkLogic. And even those folks that built their own state exchange, California, when somebody comes to enroll, eligibility determination, eligibility verification, that goes up to the Data Services Hub, which is MarkLogic. So every single person that goes through the Affordable Care Act and gets insurance is using MarkLogic. And we did this on a scale that is just enormous. It was hard doing a single state exchange. Right? We did the entire country. And this program, certainly, it was fraught with a lot of bad publicity, and it's a political hot potato. Right? I mean, basically the folks that built their own state exchange, they're Democrats. Give us your money, we'll set up a system, we want to use it. The Republican states said, don't want your money, not really into it, you build it and we'll come. So it's still a very hot topic in Washington. I'm sure it is out here as well. But what we did with this type of technology just flat out could not be done with relational. But it took somebody at CMS who was very forward thinking and had a lot of guts to try something new. Any questions around the Affordable Care Act or Obamacare, whatever you refer to it as? Okay. So Fairfax County, that is the county in which I live. It's about 400 square miles. It's about 1 million people, home to, I think, about 10 Fortune 500 companies, and everyone else is high-tech. We are, say the economy is very services-based. You're either working for the federal government or you're providing services or products to the federal government. So it's a very high-tech sector. The problem is, when you wanted to find out what was happening with plots of land in Fairfax County, very sophisticated county, a lot of educated folks in the tech industry. So I want to find out what's going on this plot of land that I'd like to buy. You'd have to drive up to Fairfax County. You'd have to give them your request. They'd have to go through Relational and Esri to find the plot. They'd have to go through the mainframe to pull some reports and some data. So from the time you walked in there and wanted that information, 30 to 60 days, they'd send you something in the mail, right? You gotta be kidding me. I mean, so what's interesting is most of the folks in Fairfax County, I wouldn't say they're, young, but they've got a lot of kids, is when the new generation, everybody in the workforce is, I forget, are they Gen X, Y? I don't know. But the younger folks, when they come into the workforce and they demand services from the government, we got to pick up our game. I mean, these folks have been buying stocks, cars, houses, everything's over the internet. And they have all this great self-service and they can get access to, and they transact, right? They're not going to wait in line. Okay, so what Fairfax County did is, this didn't work. They tried to integrate the mainframe data with the into the relational, didn't work. So what they did is they brought in MarkLogic. So what happened is we pulled data off the mainframe. We got feeds from the Oracle Esri database for the geospatial information. And they had a consolidated view of all of that information, who lived there, the history of the plots, whether there was ever an EPA issue with the land, whether there was toxic chemicals, if there was a building permit on it for development, right? You could get all of that information, but the information behind the firewall versus the public-facing system was just a little bit different. Because what they didn't want to do and put out to the public is provide the addresses of judges, police, politicians, salespeople. So today, Fairfax County uses MarkLogic for 7 or 8 different applications. I suspect you've got something similar in the counties, or if not the state, where people want to pull up plot of land, see the history of it. You can use this from your cell phone, your iPad, whatever. Let's see, does this have the address on it? I think I went the wrong way. Okay, so you should be able to log on Fairfax County and kind of check this thing out. So let me get here. I lost my presentation. So we're about towards the end anyhow, but so if you look at MarkLogic, we have customers all across different lines of business. We are running about 30% of the world's derivatives contracts through MarkLogic. We replaced 20 SQL databases into one instance of MarkLogic. We're in the intelligence community. We're providing health care to millions of people who would not have had it. We are being used for, when you go to the airport, there's this thing called a watch list, which tracks bad people. That's MarkLogic. When you go to international borders and you may run into the Customs and Border Patrol, that's MarkLogic. So we've got a really interesting use case in SOCOM. So that's Southern Command Special Forces. When they go overseas and put themselves in harm's way and protect the homeland, they've got mobile capability using MarkLogic. So MarkLogic will work in the desert of Afghanistan. I'm sure it will work in your data center. So really interesting technology, but it does require a different way of thinking. And what may hold some of you back is that you have long-held beliefs that you need to put things in rows and columns and do a data model. Right? That's what stops a lot of people, because this is a different way of thinking. So that's my piece. I'd like to turn it over to Philip. Philip was at a conference yesterday around some law enforcement down in San Diego, and there were some pretty interesting use cases that you might want to share with the folks.
Absolutely. Thank you, Kevin. Now, I do not guarantee the smoothness factor that Kevin's bringing to the table right now. But let me give you a little background on myself as well. Again, my name is Philip. I'm a Sacramento native. I call myself a Sacramento native because I've lived here longer than any place else. I graduated from Sac State. I came up here in about '89. I think I got out in '93, '94. It's a long time ago. And after that, when I got out of college, I actually started doing some contracts for the state of California. So I'm very familiar with the state system. I've spent some time at CalPERS, Caltrans, CalEPA, DOJ, DWR. I've been around the block, so to speak, at the state of California. And we'll get to the LEAM conference, which was the Law Enforcement Information Management. We'll talk a little bit about how that deals with big data. But one of the things I also want to kind of address real quickly is what I like to call the gray matter data. And when we talk about big data, we also have to talk about the business process that evolves with the amount of data your organization has to deal with on a daily basis. And that generally kind of blends itself or skews the line between business process and business culture. Because I've been in so many organizations in the state of California that part of the business process is go see Jan on floor 2, because Jan knows that system better than anybody else. Because Jan has big data in her head. She's been doing this for 30 years in the state of California. She knows more about that program and more about that data and why it goes wrong and how to fix it and how to go out and talk to the resources to resolve that problem, that probably 65 to 75% of her day is resolving issues with data, because it comes from multiple resources. People need it for mission critical services, and it's all over the place. And there is not only a significant amount of data that we store on physical mediums, but there is a tremendous amount of data that's here. And I call that the gray matter data. And I've been in a lot of organizations where we try to enable organizations to share data. And there's a few things that can cause problems with when we talk about big data, and sometimes that's a data ownership issue. Sometimes it's a data collaboration issue. Sometimes it's, I just have too much data right now and too little time to do anything. So we're going to factor that into the business process. We're going to go ahead and factor in that we need an extra 2 or 3 meetings. We're going to have to go back to Jane. We're going to have to go ahead and ask her, you know, how do we resolve this problem? What do we do? And we're going to fold that into our big data process because we understand that culturally we're just used to overcoming challenges with data. Going back to San Diego, it's really hitting the law enforcement communities. One of the things you'll see popping up everywhere is wearables. What are wearables? Wearables are personal cameras that you can wear on your person. Google Glass didn't do so well when you had to take them into movie theaters. But these are things that law enforcement are going to be wearing in the near future to make sure that everything's going okay. In fact, in San Diego for the law enforcement information management, I went to a seminar where Oakland Police Department, all 800 police officers next year will be wearing video cameras. So let's take some basic high-level big data. I'm not good with math, but we'll try. We just average, maybe they're taking 30 minutes a day, maybe max 3 hours. Let's say that's a really low resolution. We know on your phones you like to shoot in high res, which means that's a big piece of data. You do that over time with 800 police officers who are doing that for maybe 3 hours a day, you're into petabytes of data. Now, when we talked about social media and big data, yes, big data is everywhere, right? When big data is volumes of data, big data, it crushes you with the weight storage costs, right? Can you imagine petabytes of data? You're going to get that in a year, and it's going to roll and roll. And one of the things that I learned during the criminal justice and law enforcement background is previously, if you were convicted, ultimately you would have to convict. You could get rid of the evidence. Unfortunately, now you're going to be keeping that data for 5 years.
Philip, how do you know this?
What's that?
How do you know that?
Oh, I learned that over the weekend.
Okay,
Yes, yeah.
got it.
No, we're good. And it sounds like we're also possibly running out of time. So just the background to let you understand that petabytes is real, zettabytes is real. These organizations are going to be dealing with so much data that the technology is going to be there to support you. And it sounds like we're out of time. I'll answer some questions offline. We're out there with a
Yeah,
booth.
thank you.
very much.
If anybody wants copies of the presentation or information, just come on up and we'll make sure you get it.